Hey, what's going on, guys? Today is solution day, and one of the questions that was requested was the area of the segment of a circle. And a few of you actually successfully solved this, so kudos for that. I'm going to give the solution for this, and it's actually pretty straightforward, but it does have a few concepts kind of intermingled in it. It is testing you on inequalities and manipulation of the area of circle. So the question reads, the area of a segment of a circle with unit radius, which means 1, as shown in figure 1, is 1/6 of the area of the circle. Which one of the following is closest to the length L of the arc of the segment used pi equals 3? So it wants an approximate answer, which is fine. So to calculate the area of a segment of a circle, some of you may be familiar with it, some of you may not be familiar with it, that the segment is this section here. To calculate its area, you need to calculate the area of the triangle that is, let's say, ABC, and the area of the sector as a whole, the area of the sector, which is this arc here, the enclosure there. So how do we begin? We're given the area of the segment is 1/6 of the area of the circle. So we know that the radius is 1, so pi r squared by 6. That's the area that's given to us. And we know the formula for the area of the sector is r squared theta. Let's assume the arc angle theta. Okay, so that's the area of the whole sector minus the area of the triangle. Now, how do we calculate the area of the triangle? Let's take a look at this triangle right here. Okay, this is theta. If we drop an altitude here, these angles for a sector of a circle, well, they'll become an angle bisector. So it's going to be half angle. And if the radius is on this side, you've got your base is r sine theta by 2 plus r sine theta by 2. That this is your theta right here, and the altitude is r cosine of theta. Okay, so the area of our triangle is going to be half times base times altitude. We know that the altitude we just calculated is r cosine of theta, so we plug that in. R is 1, cosine of theta by 2 because it's a half angle. Okay, theta by 2, theta by 2. So if this is r, you have to know your trig that this side will be r cosine of theta, and this side plus this side is the sine of theta by 2. So sine theta by 2 times 2. So this is 2 sine cosine of theta, sine theta by 2. So we've got 2 cosine of theta by 2, sine theta by 2. So sine 2a, the formula for sine 2a is 2 sine a cos a. So then this becomes theta by 2 minus sine of theta by 2. Okay, so the equation sort of simplifies itself. Equals theta minus sine theta. So they're telling us to use the value of pi as 3. They want it approximated. So this side is going to become 3 divided by 3, which is 1. Okay, so now we know that our identity is coming to, we rearrange this equation, sine theta equals theta minus 1. So in the end, we reach this identity. Now, how do we go from there? What do we do now? It's not algebra, it's sine and cosine. You can't just do an inverse sine and figure that out. But this is where the inequalities comes in. So we know that the value of sine theta lies between -1, +1. So we plug whatever is in here in our inequality here. So then adding 1 to all of this inequality, this angle theta is going to lie between 0 and 2 radians. Now the length of the arc, the formula for the length of the arc is r theta. So theta is 2 radians, r is 1, so which means the only choice that fits here in our solution, because the angle of theta is less than 2 radians, so automatically that becomes your answer. Now that would be a basic way to approach this problem, and it is still a valid solution. The other way, a little bit more advanced method, would be to use your Taylor series small angle approximation. If you use your small angle approximation for the sine series, sine x equals x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial. I think that's your series. Now, these numbers here, they start getting really, really small for small angles. So then you can technically approximate your angle to be x minus x cubed. Now, this method is not going to be something that you're going to need to know to solve this problem. We already did that by basic inequalities. But if you were to go further into trying to approximate that, then this is how you could do it. So if you solve this equation here, the value of this will become equals x minus 1. Yeah. So then we end up getting the value of x. If we solve this equation right here, the value of x will come something like cube root of 6, which is like 1.8 something, 1.83-ish. So the answer somewhat comes in. So it says, which of the following is closest to the length L? So that's another way of doing that. But you don't really need to go this deep to solve this particular type of question. You can use just basic inequalities, area of the segment equals area of the sector minus area of the triangle. So the area of the triangle, remember that is half r sine theta by 2 times r cosine theta by 2 times 2. So basically half times the base is 2r sine theta by 2, and the altitude is r cosine theta by 2. So 2 sine theta by 2 cos theta by 2 becomes sine theta, so r square sine theta. So that's your area for the triangle. Area of the sector is half r square theta. So area of the segment formula you can derive as half r square theta minus half r square sine theta. Okay, well, that's it for today. We're going to tackle some other questions another time. And thank you for watching. Be sure to send me a message on Normal Schooling on Facebook if you want a particular question answered, and I'll see if I can do that on my next session as I have the time. Thank you very much. Thank you for watching.